Klaus. So good luck.
Hello, so I have the honor to conclude this amazing 1.5 days of presentation before we hit the last roundtable. My name is Luc Vuilleumier, as you probably saw in the picture. I'm not Klaus Temmel, I'm replacing him today because he has an important client meeting. We were talking a lot about digitalization, Internet of Things, connectivity in the last 1.5 days. And I would like to show you today what kind of technology and Siemens is deploying today to bring these concepts and ideas to the world of road traffic management. I think it's quite obvious the benefits of autonomous car, but more and more it's also understood what kind of significant challenges this kind of system can bring to the road infrastructure, especially also in a transition phase. So first of all, they can create a lot of additional demand because you have a lot of new use cases. You can drop your kids to the friends, you can pick up your groceries and so on. And it has also the potential to flood the street with so-called zero occupancy car, which are on their return travel. So in order to keep the cities accessible and the traffic flowing, you need to steer and manage the traffic flows, but also these assets. And one piece is the car to infrastructure communication. It certainly won't solve all the problem, but I think it's a core piece to manage these challenges. So just autonomous car by itself, it's not sufficient. So a car has knowledge about its status, speed, where it's heading to, but we strongly believe you have to complement the intelligent vehicle also with intelligent infrastructure, which has we can see around the corner, hidden object detection, and also has knowledge about the signal plans and the network-wide traffic strategy. And then the third layer is the central traffic management system, which optimizes the traffic flow in a wider city-wide area with enhanced traffic strategies. So this system, which we call is a car-to-X or car-to-infrastructure communication, has two main benefits. The first benefit is safety. So we heard a lot of great examples from Ajit this morning about cars and their detection capabilities. But instead should just leave it up to the car to make sense of what he can see around him. It's much easier just to tell him directly what's going on, especially in very complex situations. So this kind of system we will not deploy all over the country, but just in some core location, intersections or sections in the city. Because these systems, frankly, they're not cheap. So here we can see, for example, a complex situation with roadworks or a wrong way driver, and instead leave it up to the car to realize what's going on. We better just directly tell the car and the driver. Another example is traffic lights. So we saw again this amazing detection mechanism, but somehow it's crazy. So we have the traffic lights, everything digital, moving into the cloud now, and we have these very intelligent cars. And between the car and the traffic light, we just have to transmit a 1-bit signal, go or not go, red or green. And we need to have a very complex detection mechanism to understand is it green or is it red. So again, instead of leaving up to the car to understand what's going on, we just tell the car what's going on. And no matter how intelligent the car is, he will never able to know how long will the signal be green, how long is the signal be red, what is the signal plan behind the intersection. So with this, and that's the second benefit, so we can increase the efficiency and the traffic flow significantly with this car-to-X or car-to-infrastructure communication. So where are we with that technology? There were a lot of, the first pilot project already were conducted in the 1990s. The technology was actually already there, but not the environment. So in 2000, then a lot of R&D projects were conducted, a lot of pilot projects, and the standardization was developed. And this is now ready. So the standards are there, the technologies is there, and it's ready for implementation now. So for example, the US Department of Transport announced that by 2019, all new models should be equipped with these car-to-X communication devices. And also a lot of car manufacturer announced that they will equip all their new cars by 2009, 18 to 20 with these devices. So that means now we can see a fast increase of coverage of these kind of systems installed in the car. So already by 2020, we assume that there are 10% of the cars with this car-to-X communication infrastructure, which already allow us to get a much better picture of what's going on the road. It will not yet allow us to do a lot of guidance, but already the transparency will help us a lot. And then already by 2025, we assume that the majority of the car will have these communication devices. So that means for the transport authorities, in order to benefit from this system, they have really to start deploying the systems now. And also there are a number of pilot projects going on. I have to say, pilot projects these are pilot projects for the transport authorities. It's not for Siemens. So for Siemens, this is now a commercial product we're selling commercially. So we are past already the R&D stage, like also the car manufacturer. These are commercially products, so we don't talk about, like autonomous car, about the future. We talk about reality now. So what are the components of such a system? First, we have the central management system. Secondly, we have the roadside unit. And third, we have this onboard unit with driver displays. And the roadside unit is the link between the central management system and the car. And then fourth, we have the communication setup, which is tying that all together. And we at Siemens, we are mainly active in the part 1 and 2. And we leave it, number 3, we leave it up to the Mercedes of this world. And part 4 to Etisalat, we already heard about yesterday from Etisalat exactly about this fourth area too. So how does this system looks like? It's called the ESCOS. So please apologize for the name. I think only a German engineer can come up with this horrendous name. It's called Ecosystem Collaborative Systems. I have no idea who invented that. And the CMS stands for Central Management System. So it has two parts. It has the Central Management System and it has the roadside unit. And the important thing is the CMS is an integral part of our sea traffic portfolio. So it's integrated in the already existing other components of the sea traffic. Sea traffic is one of the most extensive and innovative road traffic management system worldwide from Siemens with many components. You can see down. Here. So we have here just a few other systems mentioned, for example, advanced traffic management system, the traffic light controllers, or parking management system, and this CMS of this car-to-X infrastructure is an integrated part of this whole portfolio, which then communicates with the cars. It can be deployed as a standalone system, which is useful for just a pilot project, but if you really want to reap the benefits of this system, you have to integrate it into the central management, into the advanced traffic management system. And this CMS has a number of functionalities. First of all, it receives the signals from the roadside unit, which acts as a detector. So the car is sending here its position, its speed, for example, to the roadside unit. So the central management system knows about the flows, but the car also issues some special messages. For example, if there is a full brake situation or if the airbag has been activated. So the operator in the central traffic management center, he knows immediately that something happened. So they don't have to wait until they can see something on the CCTV camera that there is building up a traffic jam and something has happened. So immediately gets alerted there was a situation. And then he can react, and this is the second element here with these DENMS. This is a decentralized environmental awareness messages. He can send out to the cars. He can warn them and he can guide them. And I will show you a few use cases about that later on. And these are predefined messages with user-friendly GUI where they can issue these messages quickly to a predefined area. And the third element, it's just quite standard. It's you can manage your roadside unit, you monitor them, and also remotely support them. The second element is this, I already mentioned it a few times, the roadside unit itself. So these are wireless communication devices with a range of about 200 to 800 meters to communicate with the car. They also aggregate the data from the road before it sends them to the central traffic management system. And again, I think this is an important functionality in the core section of your city. We heard about already a few examples how many data these cars generate. And if we send all this data into the cloud in this core city from a Sheikh Zayed road, it will be very challenging. So it's very useful to already pre-filter and already do some processing on the data on the roadside directly. And secondly, it's also the security layer. So this is, they encrypt the messages and establish a safe connection with the car. Again, these are, as you can see, commercially available products now, so we don't talk about the future. These kind of systems get deployed now on the roadside. So I just would like to give you a few example use cases. How can this system be used? So for example, here we can see a road work warning trailer equipped with one of these roadside units. It's issuing a message to the car approaching the trailer, up to 800 meters as you saw. And then the driver gets the information on his onboard display that something is ahead, and you can even think about additional functionalities, as I think Scott mentioned. You could even also influence the speed of the car if that transport authority wants to do that. Secondly, the roadside unit also sends its position and its speed to the central traffic management system or center. So they know exactly where it is, what it's doing, and they can also adjust the variable message signs on the road accordingly. A second use case is this, and I already mentioned it briefly, this intersection assistant. So the signalization status gets sent to the car approaching the signal, and so we know which car are approaching the signal and which are heading away from the signal. Again, the driver gets his information immediately on the onboard unit. And there are different use cases. One use case, for example, if the signal is red, he gets information time to green. They can also allow an additional functionality, for example, an automatic stop-start functionality for the engine. Or if the signal is still green, the driver gets a message about the time to green and optimal driving speed that he can get fluently through the green wave. Or you can also get the information, now slow down, you won't make it anymore, and for safety reasons. You can also implement a few safety and functionalities here, but mainly here the safety functionalities are in the car-to-car communication, then where one car warns another car directly if he, for example, passes the red light. But again, then it can then also warn the signaling controller that something happened on the intersection. A third use case is a public transport prioritization. This kind of system already exists today. But the nice feature of that is actually it's not a dedicated system. It's just based on the already deployed Car2X communication infrastructure. So you don't need any more additional equipment. So here again, the bus sends its registration to the controller. It also tells him what kind of route he's traveling. The bus driver gets then the information about the signalization status on his onboard unit. And if we know about the bus schedule in the central traffic management system, and these are kind of systems we are starting now to integrate, we also know is the bus ahead of schedule or behind the schedule, and we can adjust the signaling plan accordingly or influence it. Because to make green for a bus who is ahead of the schedule doesn't make sense actually in terms of overall traffic flow. And also very important, this is also a new functionality compared to the current system. The bus can also send a clear signal when he passed the intersection, so the signal controller knows he can go back now to the default mode. And then there are a lot of guidance use cases. One is, we also heard about parking. So parking guidance use cases, as soon the car is approaching the car parking, he gets information about the free parking spaces, and the onboard unit can then guide the driver to these free spaces. And then there are a lot of additional use cases. I don't want to go through all of them, but for example here number 10, because we have knowledge about the network-wide traffic situation in our central management system, we can, for example, implement guiding strategies. We can already do that today with variable message signs, but you can imagine we can do that much more targeted, much more intelligent, much more agile in the future, because the car also has knowledge about where he wants to go, and together with this knowledge we can guide the car driver much more intelligent and smart. Or another functionality is here number 7, where we can warn ahead of a hazardous weather condition, because this roadside unit also can detect weather conditions, for example fog or temperature. So we can warn also the driver ahead of these situations. There are also a lot of use cases in urban areas. Here we have quite an overlap with the car-to-car use cases also. So we can either do it car-to-car or car-to-infrastructure, and these will complement each other. So this will again help the car and the driver to make sense in very complex situations. So now the key point of this car-to-infrastructure communication system, nowadays we only have quite limited visibility, what's going on the road, and we only have also very limited measures to communicate with the driver and to influence his behavior. Sometimes only with a red and a green light, and a little bit more intelligence with some variable message sign. But that's it, more or less, what we can do today from a central traffic management center. And you can imagine in the future we will have a huge amount of additional data, because every vehicle, and later on also vulnerable road users like pedestrians or bicycle, will transmit information. So we have a lot of more information, a much higher transparency what's going on, and what is very important, we have also a completely new way to communicate with the driver and to influence their behavior, either of the driver or directly of the car. And I'm sure there are a lot of additional use cases we don't even imagine yet, but they will emerge over the next few years in this area. Yeah, that's from my side, to give you an impression where we at Siemens stand currently in deploying these kind of systems. Thank you.
Okay.